This is an instructional video on finding the least common multiple. Your essential question for today is, what is the difference between the least common multiple and the greatest common factor? We'll first start with, what is the definition of the least common multiple? Sometimes we shorten it with LCM. Now, the definition of the least common multiple is the least or smallest value that is a multiple of all the numbers in a set. So, first up, it's the least, or it's the smallest value that is a multiple of all the numbers in a set. Now, typically what we're going to see is just two numbers being compared, very similar to greatest common factor. But there are going to be cases where we're going to see possibly 3 or 4 numbers also being compared as well, or the numbers in the set, and we need to find the least common multiple of all 4 numbers in that set. Now, first off, how do I find the LCM? So we have 2 strategies, very similar to greatest common factor. Strategy number 1 is make a list, compare numbers. That strategy can be very accessible for a lot of students. Some people, though, that's just a little too vague. Making lists and comparing numbers, I had to do the same thing when I was looking for the greatest common factor. So another strategy is a structured type of a list. And it's an M. So the reason why I like this one is because I think about, well, here's my number that starts at the top and then it grows as I'm going down. Whereas when I was looking at factors, I had my number off to the side and I was making the list of all the things that created that thing. So this is why I like that strategy, because I can use part of the topic, multiple or factor, to generate the correct list. So I'm going to focus on strategy number 2. Now you'll see as I do strategy number 2, you can basically remove the M and you basically just created a list and compared the numbers. So how do I use strategy number 2? What I'm going to do is show this with an example. Find the least common multiple of 5 and let's do 9. Okay. Actually, I'm going to do 15 and 9. I got to think in my head. Yes, I think we're going to be okay. So I'm going to create my giant M, and the 2 numbers that I have on top are 15 and 9. Now, the most common mistakes that students will make is they'll see this and they'll say that the answer is 3. What do you think they just found? They just found the greatest common factor. They were thinking about the parts that created 15 and 9, whereas instead we're looking at multiples. So when I think of multiples, I always think of either just that or more than that. Multiples, more. So let's create our lists. Now 15s, I can skip count, or if you want to use a calculator, you can, or if you have a multiplication chart in front of you, you can use that too. So I'm going to use 15 times 1, 15 times 2, 15 times 3, 15 times 4, 15 times 5. So I'm going to stop there and see how that goes. How about for 9? Let's see. I have 9 times 1, times 2, times 3, times 4, times 5. Let's see if we have anything in common, because remember, it's a multiple of all, or the idea of it being common, it needs to be shared. So let's take a look. Do I have a 15? No. 30? No. I see 45 in common. Do I see anything else? No. So 45 not only is the only common number on this specific list, but it's also the smallest one. Can you think of another number that's a common multiple of 9 and 15, but is not the least common multiple? I'll give you a hint. Let's take a look at 75. What if I added 15 to it? You get 90. And isn't 90 a multiple of 9 as well? So 90 is a common multiple, but it's not the least common multiple. In this case, 45 is my least common multiple. Now I want you to think about this. How is this different than finding the greatest common factor? And one more thing to think about. What if instead of 2 numbers, I was given 3? Could I find a way to alter this structure to compare 3 numbers? Could I do it to compare 4? You definitely can. Now, it's not going to be an exact M, just like when we had a prime factor, when we had greatest common factor, the F didn't look like an F anymore. But the basic idea is that I'm structuring my lists in order to find something that I need. And these things are extremely flexible when it comes to utilizing it in the way that you need it. So if I have 3 numbers rather than just 15 and 9, see I added 6 on the end, I could find a way to add 6 on the end, and it won't be an M anymore, but it still sticks with the basic idea of I'm creating a list of multiples.